Hello friends, welcome to FreeCAD tutorial, and in this tutorial we will convert this orthographic drawing into the 3D model with the help of a part design workbench. So before starting the tutorial, if you like my method of teaching, then you can support me on coffee.com. You can buy a cup of coffee for me. Your small support will help these channels to grow, and you can also visit my website mechnexus.com, where I write the articles on FreeCAD and tutorials and other open softwares which you can use in your daily life to achieve your design goals. So please visit once on my website mechnexus.com as well. So let's start our tutorial. So here is orthographic drawing, and if dimension is not visible to you in video, then do not worry, I will provide the source file and this 2D drawing in my video description. So let's start our tutorial. So here I have created a new part, means I have activated my part design workbench, and I have inserted here a new body, and now we will read our drawing. So basically, while modeling any part, drawing reading is also very important. If your drawing reading is very good, then you can design a part within a less span of time. So I will on my origin plane, and as per our part view, so we will design our base sketch on this XZ plane, and then we will extrude it with a length, and then we will make this profile, and after that we will make the circular profile and this profile. So first select exit plane and create a sketch. Now I will off my origin plane. So here dimension is 40 plus 40, so I will simply select a rectangle, and I will make it symmetric. I will select this and this and this. So here is a conflict, so I will select this and I will delete it, and its thickness is a 15 mm, so I will give here 15 mm. If you are not able to read the dimensions, then follow my steps how I giving the dimension, or you will able to refer this 2D drawings once I upload it in a video description, which you can easily download. But in fact drawing quality is not good. It is only visible the dimension when you zoom the drawing. So I have made it symmetric, and this would be the 80 mm, 40. Now I will extrude it. So extrusion length would be, here the length is not given in a top view, it is in the third angle of projection, because we can see the boss here. So I will close it. So I will make it 80 by 80. Here is a dimension given because it is a third angle projection, so we can get the dimension here. So it is a 80 by 80. Now we will click on the pad and give the 80 mm, and in this case this symmetric to the plane is the most important. So we have made the base features. Now we will make this profile. So for this I will again on my origin plane, and I will select this XY plane, and I will create the sketch, and I will off my origin plane. So here is a radius 25. So before drawing this radius I will project this outer edge, and then I will select the 3-point arc, and this arc will be the tangent, so here edge is not visible because in the mid section, so we will switch to the wireframe view. So this is the 25, so I will select this and I will give my radius 25, and then I will again draw a radius of R100. I will select the 3-point arc, and I will make it tangent, and then I will again draw a 3-point arc. I will select this and I will draw a 3-point arc, and this would be the 19 mm. I will select this and I will give the radius 19 mm, and I will make it something similar to this, and again I will draw a 3-point arc for this radius R10. I will make it tangent, and again a 3-point arc of R30. So parallelly we give dimension as well. So this is the R10, and again a 3-point arc, and this will be the tangent, and again here the 3-point arc. I will delete the conflict, and now we will constrain it. So this center to origin is 95, so I will give the vertical dimension 95, and horizontal one is a 75. So I will select my origin point and this point, and I will give the 75. So once we constrain everything, then we will get a similar sketch here. So we will go one by one, and this radius is a 100 mm. So I will give the 100 mm, and its position from this center is 11 mm. So I will select this point and this point, and I will give the vertical distance 11 mm. I will move dimension to the outside, and this radius is 38. So I will give it a 38. I will move the 10 mm outside. And here I will make it tangent this point, and this one make it tangent and tangent. Now we have given 25. Now we will find out the degree of freedom of each one. So here is the degree of freedom. So this will be R25. In fact, this radius is not given here, but we will consider it. Not R25. We will give the 15 mm. This is the 38. This is the 10. So now we can see that this is the unconstrained. So if we see here, so we can find out that it is a 8 mm wall thickness. Okay, so for this we need a construction circle. So without this we would not be able to fix this. So we will draw a circle and make it construction, and its diameter is 38. And this would be horizontal. Okay, so this is the constraint. Now this would be the 8 mm wall thickness. So for this we will draw the construction line, and then a 3-point arc, which would be the tangent, not tangent, there is a straight portion is there, but here it would be the tangent. And this would be the vertical, and I will trim it. Okay, so now this would be concentric, so I will merge this. So now I will give the outer one is a 30. So I will give the radius 30, and this would be 38. So we have got the wall thickness of 8 mm. Now this and this would be the tangent. So now we have got our profile. Now we would make it constrained, because that would be not the part of our extrusion. So I will select this and this, and make it construction. Okay, so this is how we have created our profile. Now we will come out of the sketch, and we will switch to the flat lines, and now we will make a pad. and we will keep it up symmetric to the plane, and its thickness is given here in a sections of 8 mm. So I will give here the 8 mm, say OK, and now we will on our origin plane and select our mid plane, and I will create a sketch. I will move my icon here, so I will click on the sketch, select our mid plane, and then we will off our origin plane, and now we will project this arc, and diameter is 38, so this is the 38. So we will just make a coincidence constraint here, and we will constrain it. Now if you see in the top view, the extrusion length of this circular boss is a 60. So I will come out of the sketch and click on the pad and click on symmetric to the plane and give the 60 mm, right? And now we will make this cut later. Now we will make our this feature. So for this we again select a mid plane. We will on our origin plane and select this XY plane and create on the sketch. Then we'll off it. Now we will project this edge. Click on convert project geometry. Now I will project all this. For better visibility I will switch to the wireframe, and I will draw the 3-point arc to the projected point. Now I will make it tangent. I will make it tangent. I will merge the center. So some conflict is there because it should not be fully constrained. So this is some different point. We will delete it. Now I will select this one and this point. Okay. Now the last arc. So the trick here is that you just snap to it. So when it show the tangency, just drop it. So it will automatically maintain the tangency. Now here it is not green. So select this point and this and click on merge. So there is a problem in merging. So I will make a tangent relation, that will be good. Okay, so this is the constraint, and now we will project this one. this edge and draw a line and then 3-point arc, tangent, and then convert this one. Okay, now draw a line and make it tangent, and also I will make it vertical. And this radius is R30, so I will give it 30, and here I will give the tangents relation. Now here it is unconstrained, so we will do horizontal relation between these two. Okay, so now if we rotate our sketch, so here is our profile is open, so I will close it. So here is some problem, will delete it, and I will also close this one. So very simple trick is I will select a 3-point arc, and you can see when you make closer to the circumference it show the tangency. Now if you move here it will not show, but if you make closer, so just drop it and delete the conflict. So the thing is I will merge this. I will delete it and I will again draw a better. I will try to give the tangency. Okay, so we have a fully constrained profile. Now if we see its extrusion length is 40, so I will close it and click on the pad and switch to the flat lines and give the extrusion length 40, and we will keep it symmetric to the plane. Now we will say OK. So we have made approximate shape. Now we have to adapt the slots and holes inside the model and this boss here. So for this we will first cover the solid parts and then we will make the hole. So now we will again on our origin plane. Now if we see that from our plane XY we will create a datum plane. So click on the datum plane and in a Z direction I will add the dimension, which is a 95 plus 22. So here I will give 95 plus 22. So you can see that a datum plane has been inserted. So I will click on OK and I will off my origin plane. We'll say isometric view, and now I will select my datum plane and I will create a sketch. Now I will create a circle. My boss diameter is 18, so I will select this and I will give my diameter 18, and its position is a 75 from the origin, so I will select this and I will give my dimension 75, and our sketch is fully constrained. I will close it and I will also off my datum plane. Now I will click on my sketch and create a pad, and here in int condition I will select up to face and I will say OK. So you can see that a boss has been created similar to our drawing. Now we will do the material removal process. So we will start from the bottom and we will create these two slots. So I will select this face and create a sketch, and I will switch to the isometric and move to the right position. Now to create a slot I will select the slot tool and I will delete this coincident constraint and I will move my slot. Now slot center to center dimension is a 20, so I will give the dimension 20. I will move my dimension outside. Now I am not able to see my origin point, so I will switch to the wireframe view. I will select this and I will give the dimension 10, and from origin it is a 30. And slot radius is R5, so I will select my arc and give the radial dimension 5. Same way on the other side I will give the slot, and now I will make it horizontal. Same way this one, and give the dimension 30. Slot is R5, so I will make it equal. Okay, so our slot is fully constrained. Now I will close my sketch and switch to the flat lines. Now I will click on the Extrude Cut and I will say through all, say OK. Now we will select this face and create a sketch, and we will project our circumference of circle, create a circle, and cut diameter is 20. I will say extrude cut, will say through all, say OK. Now from this top boss there is also hole of a diameter 8, so select this face, create sketch, and project the circumference, create a circle of 8 mm, diameter 8, close, extrude cut, and from here select up to face, say OK. So we have made this material removal, but here is also a cut. So I will select this face and this surface, create a sketch, and I will switch to the isometric view and then top view. So this is a 30 by 5. So I will create a rectangle, and give the fillet to this and this, this and this, and I will give this radius as a 5 mm. Similarly this one and this one, made it equal, and give the 5 mm. So here is a conflict, so I will better to delete this line. And join it. Make this and this equal. We'll edit the sketch. Simply I will give the dimension 5. I will switch to the isometric and then top view. I will simply delete it, and I simply draw an arc first, and this side I will also draw an arc, and I will make this and this vertical, and this vertical, and I will make it tangent, and I will delete this constraint. And now this is the 30, so So I will select this point and this point and give it 30. This to this is 15. And add the tangency, and I will close it and say extrude cut, and I will say through all. Say OK. So we have successfully converted this orthographic drawing into the 3D model. Now I can also show you the 3D isometric view. So you can see that we have successfully converted this orthographic drawing. If I relate with this isometric view of image, I just rotate it and show you exactly. See, we have successfully made this drawing with respect to our isometric. So this is all about this tutorial, and before closing this tutorial we will give some material. So I prefer to give to the chrome. So this is how we have made this beautiful model with the help of a part design workbench in FreeCAD. If you like this tutorial, then please like, subscribe and share my channel. Your small support will help these channels to grow, and at the same time also visit my website mechnexus.com for more FreeCAD info and tutorials, and also visit my coffee page on coffee.com. Your small support will help these channels to grow and motivate me to create more awesome content on FreeCAD. So this is all about this tutorial. Thank you for watching and thank you for your valuable time.